All right. So this the the whole spectral lines that you saw yesterday. Here's the point. So as you look at hydrogen gas, which stars are made out of, they had a certain signature for their lines. Something like this. Okay. And so when astronomers looked at that, at stars, they noticed that the lines had been shifted over a little bit. And they're like, let's recalibrate our measurements or instruments. And they still found the same thing. They said, hey, other people look at this stuff, and everybody agreed that things were shifted over. So then they thought maybe it's the atmosphere. And so the Hubble telescope was the first one that they put out in space. And the Hubble telescope also confirmed this shift towards a longer wavelength and longer wavelength and smaller frequencies. So the conclusion was the stars are demonstrating Doppler effect, and the light waves are, as stars go away from us, the frequency is less. So that's how we figured out the universe was expanding, from this shift towards the red end of the spectrum. So all right, for the lab quiz, the pendulum lab. I want to encourage you, challenge you, something to like make connections between math and physics. Okay. I gave you straight away at some point. The hope was that you would build this equation, but then at the end of the day, I gave that equation to you. Okay. That's the equation that defines the period for a pendulum. Okay. And then I was asking, hey, does this produce a linear graph? Okay. My hope is that you're able to write this like you would a math. Okay. Does that make sense? Here's your independent variable. That's your dependent variable. Like in math class, you would just do this. And then come up with what's over here. Okay. At a very basic thing, you could say this. Y is proportional to the square root of x. Does that make sense? Does this produce a straight line? No. So like 0, 1, 2, 9 would be 3. It's doing something like that. Does that make sense? Okay. That's a really good skill. Not only having this class, but like just in general, like being able to like, they're going to give you equations in life for marketing, for sports management, and be able to like take the context and like boil it down to like, hey, I've done this in math class. It's no big deal. Okay. So that's the pendulum lab. The other two labs dealing with waves. Here is the big takeaway. I'll pause this video momentarily. So with the wave, so like the online lab and the spring lab, here's the big takeaway. Ready? The speed of a wave is independent of anything you can do to that wave. Independent of the amplitude, independent of the harmonics, independent of the frequency, independent of the wavelength. There's nothing that you can do to a wave to change its speed except to change the medium through which it travels. If you can change the medium, then you'll change the speed. But everything else will not change the speed. Okay? Good with that? Like, is that locked in? Please don't miss that tomorrow. Okay? Everybody good with that? That is, if you had something else calculated or you did something wrong. All those like experiment, the spring equation, sorry, the spring lab, all the speeds should have been relatively the same, except for experiment 3, where you changed the tension, which changes the medium. Okay, good with that? So the test tomorrow, it's gonna feel a little bit more like a normal physics test, other than last chapter was predominantly like very much weighted towards the conceptual side. This one has a good mixture of math and concepts. Okay, the hardest math part, in my opinion, are the decibels. Okay, if you're given decibels, you need to find decibels. You must use a calculator. The only time where you don't have to use a calculator for the decibels, if it follows the pattern, oh, that's twice as loud. Oh, that was twice as loud as twice the volume. If I say anything regarding twice the volume, twice the loudness, then it follows this pattern. 10 times the number of sources and the intensity. Number of sources and intensity go hand in hand. It's plus 10 for the number of decibels if you double the perceived sound. Okay, so if you double the perceived sound, or you have the perceived sound, that is the only time that you can not use a calculator. Okay, you good with that? And it follows that memorized pattern. Other than that, you need to use a calculator. Okay, and that's all I got. Any questions, general questions for the test? Okay.